This is the best SAT strategy training video on the internet. If you're looking to boost your SAT score, you're in the right place. And I'm about to share the most effective strategies that have helped hundreds of students. And these are not generic tips that you will find everywhere. These are the proven tactics that actually work. So sit back, grab a cup of coffee, and just follow along as we break everything down step by step. So let's get started. I am beyond excited to kick off the SAT Dream Score Masterclass. I will be talking about box and whisker plots. Then I will be talking about absolute value equation solutions. And after that, probability with multiple events. So, are you guys ready right now? Drop a yes in the chat if you guys are ready. Awesome. So, let's get started. So, let's first of all start off with probability with multiple events. And first of all, there are two types of probabilities, and the first one is with replacements, and the second one is without replacements. And we will go over each and every single one of those in this masterclass. So the first one is without replacement, and we've got a problem here, the SAT question, and I will be showing you live how to solve it right now. So let's start off with reading the question. So a bag contains 12 red chips, 6 blue chips, and 2 green chips. What is the probability of drawing a red chip first, then a green chip? So here we have multiple events. So the first event is drawing a red chip, and the second one is a green chip. So how many red chips do we have? Well, we have 12 red chips. So that's the first thing that I'm going to write, 12. And the total amount of chips, 12 plus 6 plus 2, that's going to be 20. So 12 over 20 would be my first draw, which is probability of drawing a red chip first. And we also have the second event, as stated here, then a green chip. Now, there is one big mistake that many students make, and that is multiplying it by, so how many green chips we have? We have 2 of those, so 2 over 20. But this is a mistake. You don't have to write 20 here. In fact, you have to write 19 here, because we already chose one red chip for the first one. So we can remove one chip. So that's why we're going to multiply it by 2 over 19. And that is going to give us, let me use my calculator for this. So 12 multiplied by 2 over. So we get 24 over 324 over 380. And that's going to equal to 6 over 95. So is this clear to you guys? Drop a yes in the chat if it's making sense right now. And after that, we will move on to probability with replacements. So here we have the second question, and we have multiple events with replacements. So a bag contains 12 red chips again, 6 blue chips, and 2 green chips. What's the probability of drawing a red chip first, then a green chip if the first one is replaced? They will clearly state if the first chip is replaced in the question. So in this case, they're telling that it's replaced. So as you know, the first draw is 12 over 20, as we did in the previous question, multiplied by, and in this case, because the first chip is replaced, we're not gonna subtract 1 from 20, so that's gonna be 2 over 20. It's not gonna be 2 over 19 because the first chip is already replaced. So in this case, that is gonna be 24 over 400. And that's gonna give us 3 over 50. And our solution will be 3 over 50. So, is this making sense right now? Drop a yes or some sort of a variation of yes if this is making sense for you. So now let's move on to the next question, to the next topic. So now we will cover absolute value equations. And when absolute value equations have one solution, absolute value equations have one solution when the absolute value equals 0. Here's an example of it. So x minus 9 in absolute value equals 0. So in this case, because it equals to 0, there is only one solution, x equals 9. And absolute value equations have no solution when the absolute value is set equal to a negative number. So in this case, x plus 2, and that's going to equal to negative 5. Just a second, guys. I'm going to be back right now. Just a second. Awesome. So let's move on. So as I already told, absolute value equations have no solution when the absolute value is set equal to a negative number. In this case, x plus 2 in absolute value equals negative 5. Out of absolute value, there will never be negative value, so that's why it's impossible. That's why there is no solution. Well, absolute value equations have infinite solutions when absolute value expressions on both sides are identical. So in this case, both sides are identical, so it's always true, so there are infinite solutions. Now let's practice. And also the other thing is absolute value equations have two solutions when the absolute value is set equal to a positive number. So in this case, x plus 2 in absolute value equals 5. So 5 is a positive number, so there are two solutions. Now let's have a look at this problem. Well, it says for which value of k does the equation have exactly one solution? Well, as I already told, we already covered when absolute value equations have one solution. So the first thing, you can actually write the answer in the chat if you want to. And I can probably wait a few seconds for that. Okay, awesome. So now let's solve it. So firstly, what we want to do is we want to rewrite this thing as this. So 0.5x minus 12 equals 20 minus k. And here what we did is we subtracted k from both sides, so that's the exact same thing. Now, let's consider when there is exactly one solution. Well, one solution happens only when this thing equals to 0. As we already covered here, so one solution. So absolute value equations have one solution when the absolute value equals 0. So that's why this thing, 20 minus k, should equal to 0. And from this, we can get that k equals 20. So that's the first thing. And now, if you look at, so the next step is, so we already know k equals 20, right? Now we can rewrite it as this. So 0.5x. Oh, we already found the value of k, so that's gonna be 20. K equals 20. So let's move on to the next question. Which of the following has no solution? And we have a set of answer choices right here. So let's solve it. So the best way to solve it is by testing each choice here. So in this case, let's start off with testing choice A. So in this case, we can subtract 3 from both sides, and that's gonna be x minus 4 in absolute value equals negative 2. Well, absolute value can't be negative, so it has no solutions. And we already found the right answer. But still, let's test some of the other answer choices right now. So choice B, 6 minus 2 in 5x minus 7, and it equals to negative 10. Well, the first thing is dividing both sides by negative 2. No, the first thing is actually adding 6 to both sides. So that's going to be, we can eliminate this. Oh, negative is still there. And that's going to be negative 16. And after that, if we divide it by 2, that's going to be 5x minus 7 equals 8. Because negative 16 over negative 2 is going to be 8. And as you can see, it's set equal to a positive number. 8 is a positive number, so that's why there are 2 solutions. And we want no solution, so that's why B is wrong. Now let's look at choice C. 3x plus 1 equals 7. So as you can already see, 7 is a positive number, so it also has 2 solutions. So we can remove C as well. Now let's have a look at choice D. In this case, we can, this is actually the same expression as 2x minus 6. So these two absolute values are identical. So it's true for all x values. So that means there are infinite solutions and we want no solution. So that's why D is also wrong. So let's move on to the next one. And now we will cover box and whisker plots. So let's get started. Are you guys ready for box and whisker plots? Because this is gonna be the one that is gonna be the most exciting one. Are you guys ready? Drop yes in the chat if you guys are ready. Awesome. So let's get started. So here is an example of this sort of a plot. And right now I will be showing you exactly. So these plots have firstly a minimum. So they have the smallest value and it's left whisker end. So this is gonna be this minimum value, as you can see. And this is considered the smallest value of these plots. And the second thing is first quartile. And it's the 25th percentile. And they are these things right here that I'm drawing right now. So these are considered first quartile. Then we have median, and it's the 50th percentile. And it's the line that you can see inside the box right here. these are considered as median. Next up, we have third quartile, and it's the 75th percentile, and they're this thing. So these things that I'm drawing right now are considered third quartile. Next up, we have maximum value, and it's considered the largest value, and these are the maximum values. So now let's have a look at the question. So here we have two chemistry classes, and they took the same exam, and here are their scores. So here's the box plot of scores of class A and class B. So the minimum value is 60 and maximum value is 95, and median is at 78. And in class B, the scores, the minimum score is 65 and the maximum score is 90. And we have a median at 82. So if M represents the median for class A and N represents the median for class B, what's the value of N minus M? So firstly, what is the value of M? You can drop in the chat the first value of N. Okay, so the value of M is the median, so they're already telling us that it is 78. So M equals 78. And the next thing is the value of N. Well, N here is, N represents the median for class B, so the median here is 82. 82. So 82 minus 78, that's gonna be 4. So the answer to this question is 4. Now let's move on to a little bit of a harder one, okay? So this box plot shows the number of books read by students in 2 different grades. So the minimum number of books read by students in grade 9 is 2 and the maximum is 14, and the median is at 7. So in grade 10, the minimum is 4, the maximum is 12, and median is 8. So which statement is most accurate? So choice A. Grade 9 students read more books on average. Well, the big problem with choice A is this word, average. Well, here we don't have average, and this box plot, average, which is mean, is not given. So we only know the median here and ranges, so we can't confidently say that. We cannot talk about averages here because we're not confident about them. So, and they're not given in this box plot. So A is wrong. Choice B, grade 10 students read more books on average. Well, here they're also mentioning average, and we don't have averages here. So B is wrong. But the biggest trap is actually choice B, because a lot of students see that the median is at 8, so they think that, well, grade 10 students read more books because the median is higher. But that's actually wrong, because we're not given any averages here. Choice C, the median number of books is higher for grade 10. Well, yes, because median at grade 9 is 7 and at grade 10 it's 8. So 8 is bigger than 7. So that's why choice C is correct. And now choice D. Grade 9 has less variability in reading habits. Well, no, because yes, we do have something about variability, and variability here is like range. So range here is 14 minus 2, that's going to be 12. And in grade 10, it is 8. Grade 9 has less variability? No, it has higher variability. So yeah, that's why choice C is the correct answer. Now, let me talk about 2 paths that you have if you want to improve your SAT score even further. I know these tactics were great and you might have learned a lot of stuff. You learned about box plots, you learned about absolute value equations, and you also learned about all these dates like whisper plots and quartiles and everything. But still, if you want to improve your SAT score, you should continue doing that. So there are 2 paths that you have. Well, in the first path, I'm sure that I've seen some vaults around there too. And no, seriously, you might be thinking, so before moving on to those 2 paths, let me ask you one question. What is your biggest SAT struggle right now? You can drop that in the comment, in the chat here right now. What is your biggest SAT struggle right now? Awesome. I see a lot of answers. Great. So, and there is one solution to all of these problems. And I will be revealing that solution in this masterclass. So the first question is, if you study 10 hours a week before the SAT, will you score higher than if you studied 30 minutes a day for 6 weeks? You can drop true or false in the chat right now. And let me tell you, it's false, because you will actually score higher if you study 30 minutes a day for 6 weeks rather than studying 10 hours just the week before the SAT. Why? Because you will have a day-by-day system. If you study 30 minutes a day for 6 weeks, that's way better than studying one time really long study session. And let me talk about why a day-by-day study system works. Well, firstly, you will have clarity. You will know every single day what you have to do to improve your SAT score. Next up is consistency. You will know exactly, and like each and every single day, there will be a worksheet, and if there is a day-by-day system, there will be a lot of habits, and habits stick because they're short and they're daily reps. Next up is compounding effect. Every single day builds on yesterday. That's why a day-by-day system works. Next up, retention. Your brain actually remembers way better because you repeat these things often, every single day. And lastly, your confidence will go up because every small win builds your confidence, and you can start scoring higher, and you'll always have these thoughts in your head, yes, I'm improving. And drop a mind-blowing emoji in the chat if you think this is mind-blowing. If you think that day-by-day system is really important. And let me tell you, the SAT is just like the gym. You don't get abs by doing 300 sit-ups the night before summer. You get abs by doing 30 sit-ups a day for 3 months. And it's the same with SAT scores. Small, consistent effort is way better than giant cramming. And here's a mini exercise for you right now. If you study less time per day, but more consistently, you'll score higher than someone studying randomly for longer hours. Is it true or false? Drop in the chat right now, true or false? Well, as you might have guessed it, it's true, because daily prep is more important than randomly studying for longer hours. And the next question is, do you need expensive $100 hour tutors for that? For this daily system for you to prep every single day? True or false? Well, false, because and the next thing, do you need to study 30 to 45 minutes a day for the SAT? True or false? Drop in the chat right now. True or false? Awesome to see your answer. So it's true. But there is one big problem. And that is, you don't actually have a day-by-day SAT system right now. Well, I'm gonna show you new SAT system that can get you to 1500 plus in 60 days. So that you can finally escape 1200s and finally hit your dream score with the world's first day-by-day SAT blueprint. And this blueprint is built to cut through the BS, save you time, and get you the score colleges cannot ignore. And fortunately, you can say goodbye to random YouTube advice, overpriced tutors, endless prep books, and wasted study hours. The thing is, getting a dream SAT score in 2025 isn't about doing more. It's about following the right system. Until now, that system didn't even exist. And let me tell you, you can increase your SAT score by 150 plus points guaranteed with that exact same system. It sounds bold, right? But I'm not here to convince you I'm better than free practice questions online or tutors charging $200 hours. I actually guarantee it. Yes, I will add 150 plus points to your SAT score, or it's 100% free. Well, why does this 60-day SAT system outperform every other prep method? Well, because it's built different. Firstly, there is a day-by-day structure, which most programs don't even have. Next up, it's backed by real SAT data, and it's also battle-tested by 126 students. And let me tell you, it's the straightest line to your dream score. And you may be thinking, what exactly is the 60-day blueprint? Well, it's a day-by-day SAT prep system that can remove all the guesswork from you, and instead of drowning in prep books or random practice test questions that you can find online, you wake up every single morning knowing exactly what you have to do, whether it's reading drills or math raps or a certain skill that you have to practice, and they're all mapped out across 60 days. And it's literally like having a private tutor in calendar form. And I know you might have a thought, well, will it work if I'm stuck at 1300 or lower? Absolutely. This blueprint was built for students starting anywhere. If you're below 1300, it gives you structure and all the momentum to build all the fundamentals. And if you're already scoring higher than that, it will also sharpen your timing and every single skill and strategy to push you into elite scores. And you've literally seen students jump 150 to 200 points just starting from under 1200. And the question is, what if you only have 1 to 2 hours? Well, you only need 30 to 60 minutes per day for this to work. In fact, these sorts of shorter, consistent daily reps beat long cramming sessions every time. And you might also be a parent, and you may be thinking, how do I know this is legit? Well, that's a great question, because we built the blueprint from 1000 plus SAT problems, refined it with real students, And we literally back it with a 100% score improvement guarantee. That means if your child follows the system and doesn't improve, we take the risk, not you. Well, imagine this. 3 months from now, you open your SAT score report and see 1520. Your parents are crying tears of joy. Your dream college acceptance letter arrives, and you get a $1,500 a year merit scholarship, and your friends ask how you did it. And 4 years from now, you're walking across the stage at your dream college. You saved $60,000 plus in scholarships, and you have amazing opportunities because of your school's network. And you're stress-free about student loans, and your future is completely different. And now, imagine this. All of this because you made one decision right now. To stop studying the wrong way and start following the 60-day SAT blueprint. And you may be thinking, well, what our students are saying about it? Well, we already got 120 positive ratings, 62 super helpful reviews from our students. And here's what our students are saying. And let me tell you about what you get in this program. Firstly, you will get a 60-day SAT blueprint. Next up, you will have an elite community access. You will also have live coaching. You can ask me anything and get direct feedback. And I even record and answer custom videos for your questions. You will also have a daily Q&A with me. And make sure to save your spot until October 26th because the launch price is $97 a month. In fact, if you join the 60-day blueprints before September 26th, you will lock in 2 one-on-one sessions with me, and you can use them to improve your SAT score, to fix your weakest section really fast in these 2 one-on-one sessions with me. You can also get personalized feedback on practice questions. You can ask questions that you cannot find answers anywhere else. And this is really great deal, I would say. And then after that, the base price is going to be $149 a month, and the future price after 50 members will be $197 a month. Well, you might be thinking, why are you doing this? Well, because I want to reward the early action takers, and I want to keep this community and this blueprint exclusive. And I have a bonus. Only for the first 5 members right now, you can get 2 one-on-one tutoring sessions for free if you join. And make sure to act right now and secure your spot. And have 2 private sessions with me. These are the 6 SAT prediction questions for your exam, and let's start off with the math section. Just so you know, I'm not talking out of thin air. I got 780 out of 800 in SAT maths. So let's get started with prediction number 1. The table shows Evergreen National Park visitors for 2015 and 2025, but the way the years are listed is not directly what you plug into the equations. So the question asks for V of t, the number of visitors t years after 2015. So t equals 0 corresponds to 2015, and t equals 10 corresponds to 2025. Now let's plug points into the answer choices instead of building the line from scratch. So let's start off with t equals 0. In 2015, there are 450,000 visitors, so we need an equation that gives v of 0 equals 550. So let's look at the options. Choice A, 450 minus 6 multiplied by 0 equals 450. Choice B, 450 minus 60 multiplied by 0 also equals 450. So A and B are correct when t equals 0. Choice C, so that would be 450 minus this crazy number, so that's wrong. Choice D, 450 minus 6 multiplied by 0 minus 2015. So that would be 450 plus that sort of crazy number, so that's also wrong. So C and D are clearly wrong here. Next, we should plug t equals 10 for 2025. So we want v of 10 equals 390. Choice A, 450 minus 6 multiplied by 10. So that would be 450 minus 60, which equals 390, which is something that we want. Choice B, 450 minus 60 multiplied by 10. And that would be 450 minus 600, which equals 150, which is not something that we want. So this confirms it. A works perfectly. You just have to plug points in instead of risking slope calculations with all these fractions and negatives. And students often mess up by just trying to track the actual year numbers or miscalculating slope. So plug and play keeps it very clean and safe here. So here they're asking us to determine triangle congruence based on given sides and angles. So we have triangles PQR and STU, with PQ equals ST, which equals 9 centimeters, and angles P equals C equals 45 degrees. So they want to know which additional information is sufficient to show that triangles are congruent. So let's look at these statements. Statement number 1 says angles Q and R are equal. While knowing that two angles are equal can help, on its own, it doesn't really guarantee congruence because we don't really know the sides opposite them yet. Statement 2 says PR equals SU. Now we have two sides and the included angle, which is side, angle, side, which is a classic congruence rule, and this is sufficient by SAS, which is side, angle, side, to show that triangles are congruent. Statement 3 says QR equals TU. Well, this gives us two angles and the side opposite one of them. So that would be angle, side, angle. Knowing QR equals TU is the given 45-degree angles is also sufficient by ASA congruence. So combining these insights, either statement 2 or 3 alone is enough to guarantee that triangles are congruent. So statement number 1 alone is not sufficient at all. So the key takeaway here is when solving SAT congruence problems, look for classic rules like SAS, ASA, SSS. Identify the given elements and match them with these rules carefully. To help you out, I also put together an insanely valuable masterclass where I shared so much valuable knowledge. Inside, I also break down 3 specific tactics that can help you hit your dream SAT score, no matter where you are in your SAT prep journey. And I'm so excited to finally share it with you right now. And you can grab access using the link in the description or the top comment below. So let's start by reading the story and seeing what they want. The function P defined above can be used to model the number of visitors to a popular hiking trail at different air temperatures, where T is measured in degrees Celsius above 20 degrees. Which of the following does the model predict? These answers are basically describing how the number changes as T increases. For every increase in temperatures by 1 Celsius, the number of visitors decreases by 200. So let's check that. P of 0 equals 200. P of 1 equals 200 multiplied by 0.85 equals 170. So it didn't decrease by 200%, it only decreased by 30. And that already eliminates A. Next, for every increase in temperatures by 1 degree Celsius, the number of visitors decreases by 15%. Well, P of 1 equals 200 multiplied by 0.85. And that equals 170. That's exactly a 15% decrease, and it sounds promising. But we have to check the units. T is in degrees above 20 degrees, so an increase of 1 degree Celsius is exactly what this represents. So this looks correct. Option C says for every increase in temperatures by 5 degrees, the number of visitors decreases by 200. P of 5 equals 200 multiplied by 0.85 in the power of 5, which kind of equals 84. So the decrease is 200 minus 84, which equals 116, not 200. So that's wrong. Option D says for every increase in temperature by 5 degrees, the number of visitors decreases by 15%. But P of 5 equals 200 multiplied by 0.85 in the power of 5, which sort of equals 84. So that's a decrease of much more than 15% because exponential decreases compound over multiple increments. So that's wrong too. Now, they're asking us to find the y-intercept of an exponential equation. And this can seem very tricky, but the pattern is really straightforward once we recognize it. So the function y equals c multiplied by 4.5 in the power of x minus d. And it's defined in the xy plane where c and d are positive constants. The question asks for the y-intercept, which means the value of y when x equals 0. Let's plug in x equals 0. So we get y equals c multiplied by 4.5 in the power of 0 minus d. So 4.5 in the power of 0 is 1. So this simplifies to y equals c minus this. And this is exactly how we find the y-intercept in any function. Set x equals 0 and simplify it. Now let's check the answer choices. Choice A is not correct because it ignores the negative d. Choice B is not correct because it ignores c multiplier. Choice C is exactly what we calculated. Choice D is the reverse and would be negative if c is more than d, so it's wrong. So the key takeaway is for exponential functions of the form y equals c a in the power of x minus d, the y-intercept is always c minus d, because a in the power of 0 equals 1. So always set x equals 0 and simplify it first, and this will be your safest move on the SATs. To help you out, I put together an insanely valuable masterclass where I shared so much valuable knowledge, and inside I also break down 3 specific tactics that can help you hit your dream SAT score, no matter where you are in your SAT prep journey. So I'm so excited to finally share it with you, and you can grab access using the link in the description or the top comment below. Okay, so here they're asking us to find the length of the longer side of a rectangular given a ratio and the perimeter. So this is way more straightforward than exponential stuff, but let's carefully read the story. In rectangle wxyz, the ratio of wx to xy is 7:4, and the total perimeter is 132 meters. So first, let's translate the ratio into variables. So let the shorter side xy equal 4k and the longer side wx equals 7k. We do this because ratios can be scaled by a common factor to make calculations easier. Next, remember the perimeter formula. Perimeter equals 2 multiplied by length plus width. So here, that would be 2 multiplied by wx plus xy equals 2 multiplied by 7k plus 4k, which equals 2 multiplied by 11k, which equals 22k. And the problem says the perimeter is 132 meters, so we set up the equation 22k equals 132. Solving for k equals 6. Now plug k back in to find the actual side length. So the longer side wx equals 7k, which is 7 multiplied by 6, which equals 42 meters. And the shorter side xy equals 4k, which equals 24 meters. So the length of the longer side is 42 meters. And the key takeaway here is when you get a ratio and perimeter, always turn the ratio into variables. Use the perimeter formula and make sure to solve for the scaling factor and then compute the actual length. And the SAT likes this approach because it keeps arithmetic simple and it avoids mistakes with fractions or proportions. So here they're asking us to outline the significance of its contribution to literature. So let's start by reading the first sentence, seeing exactly what the question is asking. So the student wants to outline the significance of this contributions to literature. So the key here is the significance that is underlined in our minds right now. So if we read the answer choices and ask ourselves, does this accomplish the goal? Choice A just states that he was celebrated during that Renaissance. That is true, but does it fully convey the significance? No. So you can eliminate it. Choice B mentions his poetry addressing social issues and reflecting experiences of African Americans. Well, this is important context, but it doesn't capture the breadth of his contributions, so it's wrong. Choice C combines jazz rhythms with everyday language in his poetry, making literature accessible while promoting cultural awareness. So this seems to hit the significance point because it explains how he influenced literature stylistically and also culturally. Now, choice D mentions inspiration for generations and being studied in schools. This is true, but focuses more on influence rather than the direct contribution itself. Now, we check the student's notes just to confirm choice C uses relevant information from the notes. Yes, it combines jazz rhythms and everyday language and mentions accessibility and cultural awareness, and all these points are in the notes. Therefore, choice C is the best one here because it directly addresses the significance of his contributions to literature rather than just stating facts or later influence. And if you're confident, you can skip the last step when you're in a rush, but checking notes can help you in the second module. Just as a reminder, you can watch an insanely valuable masterclass that I put together where I shared so much valuable knowledge, and you can grab access using the link in the description or the top comment below. I'm about to give you 20 hacks ripped straight from the playbook of the top 0.01% SAT test takers. And here's the thing. I spent the last 4 years dissecting every single hidden pattern in SAT math, and I scored 780 out of 800 myself. So if you've ever felt stuck plateauing at 1600s or low 700s, this is your unfair advantage. Because once you use these hacks, you will stop wasting time on silly mistakes and you will start thinking like a top scorer. So let's dive in. This one move is gonna save you from losing dozens of points on SAT math, and it's about mastering transformations. Here's the brutal truth. Most students waste minutes redrawing graphs in their head trying to figure out if it's shifting left, right, up, or down. And in SAT land, every wasted second is points slips through your fingers. But this hack flips the script. Whenever you see a function like f of x minus h plus k, don't overthink, don't redraw. Instantly say this out loud. Right by h, up by k. Done. No guessing, no scribbling, just instant recognition. Step number 1 is looking at what's happening inside the parentheses. So x minus h. And x minus h means right shift. X plus h means left shift. Step number 2, look at what's happening outside the function. Plus k means it's up. Negative k means it's down. Step number 3, if there's a negative slapped in front, like minus f of x, well, you should flip it upside down, which is a reflection across the x-axis. Step number 4 is multiplying by number c. It either stretches, which means it's gonna become skinny, or shrinks, which means it's gonna be fat. And if you master this flow, you can shave off 20 to 30 seconds per graph question. And that's easily 5 to 10 minutes banked on the test. And you know what that means? You walk out with an extra 20 to 40 points that everyone else leaves bleeding on the floor. So here's the deal. Either you burn your time redrawing all these graphs like everyone else, or you can lock this hack in right now and scoop up free points like candy. And it's your choice. And if you think this was big, wait till you see the next hack. It's even nastier. And it lets you predict SAT math answers without even solving those questions themselves. So make sure to stick around for that. Here's that dirty little secret nobody tells you about percent change and interest problems. Most students fall for the trap of adding percentages like clowns at a circuit. Price goes up 20%, down 40%, up 25%, and they try to just add them up. And that's wrong. That's why they bomb these questions. The SAT is laughing at them because the whole game is compounding. And once you know the formula, you literally crush these questions in seconds, while everyone else drowns in algebra. make sure to always multiply the multipliers. So what that means is if there is an increase by 20%, multiply it by 1.2. If there is a decrease by 40%, multiply it by 0.6. And if there is an increase by 25%, multiply by 1.25. So the final price here would be P multiplied by 1.2 multiplied by 0.6 multiplied by 1.25, and that's done. One clean line, no messy arithmetic, and there is no wasted brain power. And here's where it gets crazy. This same mindset destroys compound interest problems. Make sure to forget writing out year by year nonsense, just lock into this formula. A equals P multiplied by 1 plus R over N in the power of NT. And in this formula, P is your starting money, and this is a sort of an initial value. R is an annual rate in decimals. N is compounding per year. T is time in years. And if it's a simple interest, strip it back. A equals P multiplied by 1 plus RT. No exponents, no compounding, just linear growth. Now, here's why this is a big hack. SAT loves to disguise percent change and interest as word problem nightmares. But with this shortcut, you slice through them in 15 seconds, leaving you extra time for the real killers. That's not just time saved, that's another 20 to 30 points secured. So burn this into your brain. Don't add percentages, don't expand nonsense, just multiply multipliers, draw formulas, and move on. And listen, if you thought this hack was brutal, the next one is a straight up ambush. It's the kind of move that lets you predict answer choices before you even finish the problem. And yeah, that's the next one. So here's the truth nobody told you. Every quadratic in SAT land is screaming its secrets at you, only if you know where to look. Well, standard form isn't just an equation, it's actually a cheat sheet for students like you. F of x equals ax in the power of 2 plus bx plus c. Well, y-intercept, easy, it's just c. No math, you can just read it. Vertex, stop completing the square like a rookie. Top scorers laser in on negative b over 2a. That's your x-coordinate. Well, x-intercepts, sure, quadratic formula works, but if you need the sum or product of roots, you don't waste time solving. You just pull them straight from the coefficients. And that means sum of solutions equals negative over a. Product of solutions over a. That's it, instant answers. And here's the truth that burns students alive on SAT Math. The test isn't just asking if you know mean, median, and range. Everyone knows those. The SAT is a trap game. They want you to fall for the wrong average, the wrong middle, or the wrong spread. So the first trap is the outlier till shots. The SAT loves to sneak in one absurd number like 999 in a list of normal values. Kids who autopilot, they grab the mean and gets destroyed. You instantly check, is this dataset skewed? If yes, the median is king, and that one move nukes the trap. Trap number 2, the wrong middle. Median isn't always the middle looking number. It's the actual middle after sorting. SAT slips in unordered lists just to see if you're sloppy. So don't be. Sorts first, then strike. Trap number 3 is spread confusion. Range versus standard deviation. Range is just max minus minimum. Too easy. Standard deviation, that's about how clustered or scattered the whole dataset is around the mean. Low standard deviation means it's tight. High standard deviation means it's wide. Remember that, and you will never confuse the two again. Trap number 2, miscount. Mean formula equals sum over a number of values. Easy. But SAT loves to hide how many values there actually are, so make sure to count every single time. Here's why this is crazy. When you spot the traps before even calculating, you're not just solving them, you're eliminating wrong answers like a sniper. And that's time save it, so burn this in. Outliers equal check median, unsorted sorts first, spread is standard deviation versus range, count values every time, and that's the anti-trap system. And buckle up, because the next hack is literally the nuclear option. I'm gonna show you how to predict probability and statistic answers without grinding formulas by using nothing but common sense logic the College Board doesn't want you to know. Because this is where the SAT secretly hands you free points and most students are too blind to grab them. They see f of x equals 2x in the power of 2 plus 12x plus 19, and they start sweating, scribbling algebra, praying their vertex formula memory doesn't fail them. Meanwhile, you pull out Desmos, the College Board's own built-in calculator, and nuke the question in 10 seconds flat. Step number 1 is typing it straight into Desmos, y equals 2x in the power of 2 plus 12x plus 19. Step number 2 is tapping the graph, and boom, the vertex pops right up. That's your minimum points. Step number 3, read the coordinates. Here it's -3, 1. So the translation is like the minimum value of the function is 1. And if you're serious about cracking the SAT, stop guessing. I've laid out the exact 6-week system that gets you to 1500 plus or above, step by step, no fluff. And the full blueprint is waiting in the description. So hit the link, dive in, watch your SAT score skyrocket. Desmos is solving too many SAT questions in one click. Desmos is everything, solving even the hardest questions in 10 seconds. Sure, it feels like Desmos is everything, but what you're not seeing is how to use it the right way. Here's what most students don't realize. You don't need the quadratic formula to solve this. Desmos can do all the heavy lifting in just seconds. You're given the equation 5x squared plus 12x minus d equals 0 and told one solution is -6 plus 2 the square root of 14 divided by 5, and Desmos simplifies it instantly. D equals 4. And this is why Desmos is a game changer. Instead of spending 2 minutes grinding through the quadratic formula, you can solve it in under 20 seconds and just move on to the next question. Here's something most students overlook. When the SAT tells you a factor, it's basically giving you the answer if you know how to use it. Think about it. Some students see x minus 5 is a factor and immediately start expanding, dividing, writing out long equations. Others, they just use the root directly and let Desmos do all the work. The second group finishes it in under 15 seconds. The first group, they're still scribbling. So why does this matter? Because SAT factor problems show up all the time. If you recognize the shortcuts, you save time, avoid mistakes, and keep your momentum going. Here's how it works. We've got q of x equals x squared minus nx plus 10. So if you're told x minus 5 is a factor, that means the root is x equals 5. Now watch what Desmos does. It tells us n equals 7 instantly. That's it. One substitution, one click, and done. Now here's the bigger picture. Anytime you see x minus a is a factor, the test is handing you 3 points. Here's something most students completely miss. Exponential decay problems don't have to be scary. In fact, with Desmos, you can solve this in under 15 seconds. No messy algebra, no guessing. Think about it. Some students see g of x equals 50 multiplied by 0.75 in the power of x. You can try a full SAT English lesson for free. The link is in the description, and if you're dragging your feet with English prep, this is your sign. Click it, start the free lesson today, and see for yourself why studying SAT English just got fun. So if you're told that for any positive integer k, g of k is p% less than gk minus 1. That means, mathematically, g of x equals 1 minus p over 100 multiplied by g of k minus 1. Desmos then solves for p automatically, 25%, done in one click. Alright, here's something most students completely miss when tackling exponential functions on the SAT. Imagine you're staring at this problem. f of x equals a multiplied by b in the power of x where a and b are positive. If f of n minus 1 equals f of n plus 0.92 multiplied by f of n minus 1, two types of students right now. Type 1 is pulling their hair out, trying to isolate b, thinking, oh, how do I even start? Type 2 opens Desmos, types in the equation, and literally sees the answer in seconds. The difference? They understand how to leverage tools the right way. And that's what we're diving into next. Here's the trick. Desmos isn't just for graphing. It can solve equations automatically. Step 1 inputs the function like this. f of x equals a multiplied by b in the power of x, where a is more than 0 and b is also more than 0. f of n minus 1, title f of n plus 0.92 multiplied by f of n minus 1. Then writes b. And boom, Desmos spits out no messy algebra, no second guessing. Now imagine this applied across 3 exponential SAT problems in a row. You go from stuck and frustrated to confidently breathing through. And yes, this works every single time, only if you know how to structure your inputs correctly. Look, in the last 8 minutes, you've learned how to solve questions with Desmos in under 20 seconds. You've shifted from fighting with algebra to leveraging your tools strategically. And if you want to keep building this strategic advantage on the SAT, you need to master SAT vocabulary question hacks. And the way you do that is by watching this video next, where I will show you the pattern recognition system that lets you eliminate wrong answer choices in 10 seconds, even when you don't know the word itself. Make sure to watch that video.